In December 1941, when the smoke from Pearl Harbor still hovered above the Pacific Ocean, the U.S. War Department began to realize that the mechanized world was entering a new era. Japan's attack not only drew America into the World War, but also forced strategists to confront an unprecedented question. If the battlefield of the future was a race between speed and firepower, could America win with a weapon that was fast, easy to produce, and intelligent enough to redefine combat doctrine? While Europe was dominated by the Nazi philosophy of heavy armor and overwhelming firepower, American industry was aiming for a weapon that could be produced like an automobile, not built like a work of art. In that context, Lieutenant Colonel Andrew Davis Bruce, an artillery officer with unorthodox thinking, was assigned to establish the Tank Destroyer Training Center at Fort Meade, Maryland. Bruce had closely observed Germany's Blitzkrieg campaigns, where Panzer III and IV tanks coordinated tightly with infantry and air power to break through enemy lines within hours. Yet he saw no glory in the Panzers. Instead, he saw their dependence on terrain, logistics, and control of tempo. He wrote in a memorandum to the War Department in 1942, "Germany wins not because their tanks are faster, but because they move like a stream." From that thought, he posed the question: if America could create a weapon that was freer, faster, and more flexible, a predator that could strike and disappear before the enemy could react, then the nature of warfare itself would change. It was at Fort Meade that the concept of speed as armor was born, and later codified in Field Manual 18-5, issued at the end of 1942. According to this manual, tank destroyer forces were not tanks, but rapid anti-tank response units tasked to destroy enemy armored concentrations with accurate and mobile firepower. This doctrine introduced a new concept: mobile anti-tank response force. In the command schematics, these units were placed behind defensive lines, waiting for a signal to rush to critical points at twice the speed of conventional tanks. It was a strategy that did not rely on physical strength, but on time, the rarest resource in war. Within the Ordnance Department, this concept was initially dismissed as madness. Engineers who had served in Europe insisted that no armored vehicle with thin armor and an open top could survive, but Bruce and his advisory team argued the opposite. A vehicle fast enough not to get hit doesn't need to be thick enough to take a hit. This was the original idea that gave birth to the Hellcat. Beginning in March 1942, prototype designs were designated T-49 and then T-67. Each failure prompted further weight reduction, higher speed, engine relocation, and thinner armor. The goals were clearly quantified. It had to reach a speed of over 50 miles per hour, feature a fully rotating turret, and be agile enough to reverse direction in less than 20 seconds. These figures were recorded in the Ordnance Department Memorandum of June 1942, a document later regarded as the official starting point of the Hellcat. Meanwhile, across the ocean, Nazi Germany was moving in the exact opposite direction. From 1939 to 1943, they upgraded from the Panzer III, 23 tons, to the Panther, 45 tons, and Tiger, 57 tons. Each new version represented progress in armor, but regression in mobility. According to Wehrmacht statistics, the Panther required over 2,000 man-hours to complete and achieved a top speed of only 29 miles per hour on roads. Their philosophy was summarized by General Heinz Guderian's words: "A tank is a moving wall of steel." The Americans, however, believed the opposite. A tank destroyer should be a ghost on the battlefield. By the end of 1942, the War Department approved the official development of the T-70, the prototype embodying the hit-and-disappear philosophy. According to the Ordnance Technical Committee Minutes 17274, this model would use a Wright R975 aircraft engine, 9 cylinders, 350 horsepower, with a maximum weight not exceeding 20 tons, and armed with a 76mm gun. This configuration made it half as heavy as the Panther but twice as fast. When the first T-70 was completed at the Buick plant in April 1943, Bruce wrote in his journal, "It's not a tank, it's a sports car with a gun." The birth of the T-70, the forerunner of the M18 Hellcat, marked the transformation of American military thought. This was not merely a technological advance, but a doctrinal revolution. While Germany remained faithful to the notion that strength lies in steel, Americans began to believe that strength lies in mobility. That difference shaped the remainder of the mechanized war. According to the U.S. Army Armored Board's 1943 evaluation, the new tank destroyer concept is the embodiment of mobility as protection. That concise statement became the guiding principle for every combat vehicle that followed. As Buick's production lines began to hum and the roar of the Wright R975 engine filled the Flint factory, a new chapter in mechanized warfare opened. None of the engineers knew they had just created a weapon that would change how the Germans viewed tanks. From that moment, speed was no longer a secondary trait, it became the essence of power. And in that silence, a new kind of war was born. In April 1943, the prototype T-70 gun motor carriage officially left the Ordnance Department's proving grounds, marking the final stage in a long development chain that had begun with the experimental T-49 and T-67. The first vehicles bore no insignia, only technical serial numbers, yet the test report stated, the vehicle reached a maximum speed of 55 miles per hour, maintained stability while rotating the turret at high speed, and demonstrated mobility far exceeding all previous armored models. These results compelled the technical board to reassess the entire American tank design process. According to Ordnance Technical Committee Minutes 17672, the T-70 was selected as the standard model and officially designated M18 Hellcat. It was the moment when theoretical doctrine became industrial reality, from Lieutenant Colonel Bruce's concept to Buick's production line. When the War Department signed a contract with Buick Motor Division in Flint, Michigan, the notion of civilian industry transformed for war became tangible. More than 2,900 automotive engineers from Buick and General Motors were transferred to the Ordnance Division within 3 months. They brought with them technologies from the automobile sector, modular production, standardized components, and assembly line quality control. In an internal report from May 1943, Buick's technical director wrote, "German tanks are built as works of art, while the Hellcat is built like a high-performance automobile. That was the fundamental difference. Every element of the M18, from the Wright R975 engine to the torsion bar suspension system, embodied the American philosophy of industrialization, prioritizing performance and speed over form. The heart of the Hellcat was the Wright R975 engine, a 9-cylinder aircraft-derived engine producing 350–400 horsepower. Compared to the Maybach HL230 engine of the Panther, which produced 700 horsepower but had to move 45 tons, the Hellcat was half the weight, achieving a power-to-weight ratio of 20 horsepower per ton, higher than any tank of its time. Buick engineers mounted the engine on a sliding cradle, allowing it to be removed within 2 hours versus 24 hours for the Panther. According to the War Production Board report, July 1943, this was the only innovation that allowed engine replacement in the field without a crane. The hull was welded from 12.7mm rolled steel plates angled at 38 degrees, optimized for speed rather than armor. All of it served a single design philosophy. The best armor is not being hit. In July 1943, Buick's assembly line officially began operations. The first M18s were completed in 500 man-hours, 4 times faster than the Panther, 2,000 man-hours per vehicle, according to the Wehrmacht production office. The assembly process was divided into 17 stages, from hull welding, engine installation, and chassis inspection to the testing of the 76mm M1A1 gun. On average, a new hull left the line every 15 minutes. According to the Office of War Production Bulletin 1944, Buick's Flint plant achieved a production rate equivalent to 3 German tank factories combined. By January 1944, Output peaked at 250 vehicles per month, while Germany managed only 380 Panthers per month across its entire network. The atmosphere inside the Flint plant was described by reporters as a mechanical symphony, the sound of hammers, welding arcs, and lathes blended with the whistle of shift changes. One worker recalled after the war, "We worked 16 hours a day, ate and slept among the grey-painted hulls, and felt that every completed machine could save hundreds of lives." At the end of the line, finished vehicles were marked M18 Hellcat, their right engines sealed, and shipped to the Milford Proving Grounds. A report from February 1944 noted vehicle number 500 reached 60 miles per hour, exceeding the design specification of 55 miles per hour, while the transmission system remained stable. Low. The philosophy, assemble, not craft, was pushed to its extreme. The M18 was built as a modular machine. Its entire powertrain, gearbox, and cooling system could be detached using 8 technical pins, allowing field crews to replace them within 120 minutes. The torque drive automatic transmission, developed by Buick, replaced the German-style manual gearbox, enabling the driver to focus on maneuvering rather than shifting. According to the U.S. Army Ordnance Report, March 1944, the Hellcat can complete acceleration from 0 to 30 miles per hour in 11 seconds, while the Panther requires nearly 30. This was more than speed, it was a difference in philosophy. Americans built adaptable machines, Germans built heavy monuments. Beyond engineering, cooperation between government and industry was the foundation of success. Buick, General Motors, Chrysler, and Ford shared molds, components, and material standards, forming an unprecedented wartime industrial ecosystem. Every part of the Hellcat could be assembled in any GM plant, something German industry could not achieve due to its reliance on manual labor and fragmented supply chains. According to the War Department Statistical Review 1944, the average cost per M18 was $57,500, less than half the Panther's 117,100 Reichsmarks. By October 1944, a total of 2,507 Hellcats had been delivered to the Army, achieving an average mechanical completion rate of 98.2%. The emergence of the M18 Hellcat not only proved America's ability to mass produce, but also showed how the nation turned Bruce's theory into reality. From drawing board to production line, from concept to object, it all happened in less than 24 months. When the roar of the Wright R975 engines echoed through the Flint depots, the nature of industrial warfare had changed. It was no longer a contest between steel machines, but between two technical civilizations, one built by craftsmen, the other by assembly lines. And amid the clangor of metal, a slogan echoed across the walls of Buick's factory: "Speed is protection, production is victory." In March 1944, as the Anzio campaign entered its fiercest phase, the U.S. Army Command decided to deploy 5 T-70 Hellcats from the 894th Tank Destroyer Battalion for combat trials. The terrain of central Italy, with its low hills, winding dirt roads, and clustered villages, was hardly ideal for a machine designed to run 55 miles per hour on open plains. But the goal of the test was not top speed. It was to measure maneuverability, tactical responsiveness, and mechanical endurance under real combat conditions. According to the after-action report, 894th TD Battalion, March 1944, the terrain of Anzio is the harshest challenge the T-70 could face and the only chance to prove its worth. The Hellcats were deployed along the southern coast of Rome, near Nettuno, where German forces of the 14th Army were attempting to encircle the Allied troops. These T-70s carried no official markings, only temporary chalk symbols. In their first sortie, one Hellcat platoon was assigned to support the 3rd Infantry Division in an assault on German defensive positions along the Albano-Anzio Road. Upon spotting Stug 3 self-propelled guns on the hillside, the Hellcat crews adopted the tactic of fire shift, fire again, using superior speed to move between firing positions. Within 17 minutes, They destroyed 3 German vehicles, one completely obliterated, the other 2 abandoned due to engine fires. The report sent to command noted that Hellcats achieved an average maneuvering speed of 28 miles per hour on dirt roads, twice that of the M10 Wolverine. A few weeks later, the Special Projects Division report, May 1944, released detailed statistics. Over a distance of 300 miles, none of the vehicles required overhaul. The mechanical failure rate was only 8%, the lowest among all U.S. mechanized forces on the Italian front. The report also recorded an average fuel consumption of 1.5 gallons per mile, 30% lower than that of the M10. The operational readiness rate reached 85%, whereas the M4 Sherman medium tank achieved only 68% during the same period. These figures thrilled the Buick engineers back in Flint, as they served as the first proof that a vehicle designed under the speed-over-armor philosophy could survive in mountainous terrain, a possibility many officers had doubted. But the battlefield was no laboratory. In a report dated the 10th of April 1944, Captain John F. McCarley, commander of the 2nd Platoon, wrote, "The terrain forces us to fight by instinct, but the SCR 508 FM radio system lets us move like a racing team. When the lead vehicle fires, the one behind is ready to replace it within 5 seconds. Such coordinated speed caught the Germans off guard." A prisoner from the 26th Panzer Division confessed that the American vehicles moved so fast we thought there were 2 or 3 separate units. That very element turned the Hellcat into a psychological weapon as much as a combat. 1. The Hellcat crews quickly refined their tactics. They called it shoot and slide. Instead of waiting for counterfire, the vehicles immediately shifted to the opposite flank, keeping the engine revved high to maintain momentum. The use of FM radio allowed platoon leaders to synchronize fire and movement in real time. According to the Tank Destroyer Center Tactical Memo, April 1944, a Hellcat platoon can move 800 meters, fire, and withdraw from sight in under 40 seconds. In ambushes at Cisterna and Campoleone, they proved that speed and communication could replace heavy armor. Local Italian soldiers nicknamed the Hellcat Il Fulmine Grigio, the Grey Lightning. Whenever the Wright R975 engine roared to life, its distinctive sound echoed through the valleys, signaling to both sides the arrival of a new kind of technology. In his memoir, gunner William H. Keller recalled, "We could feel the ground tremble, but instead of fear, it felt like opportunity. When I pulled the trigger, the vehicle leapt like a cat awakened." It was not pride, he described, but the sensation of operating a weapon that exceeded all expectations. By mid-May 1944, the test results were sent back to Washington. The evaluation report concluded, Hellcat demonstrated sustained combat capability under adverse conditions, with minimal wear and highly flexible tactical response. The vehicle achieved 11 armored kills over 3 weeks of testing. Most of these kills occurred at ranges under 800 meters, confirming the precision and controllability of the 76mm M1A1 gun. According to the Army Service Forces Technical Bulletin, June 1944, Hellcat exceeds all standards of durability and mobility, suitable for mobile operations in France. From the rugged roads of Anzio, the Hellcat emerged from its trial phase to become the new tactical belief of the U.S. Army. The European Army Command immediately approved the plan to equip the 704th Tank Destroyer Battalion, slated for deployment in the Lorraine campaign. On the 20th of June 1944, a telegram from the European Theatre of Operations headquarters stated, M18 to be deployed with 704th TD, priority high, operational test successful. Those terse lines closed a chapter of experimentation and opened an entirely new phase in the history of American combat vehicles. As the sun set over the Anzio coast, the Hellcats returned to the maintenance area, their hulls still coated in dust and mud. A military engineer wrote in his diary, "They ran as if trying to leave the war behind." It was the moment officers realized that America had found the weapon that would redefine the meaning of tactical mobility. And somewhere in that dusk, speed became doctrine. At dawn on the 19th of September 1944, the Lorraine region in eastern France was shrouded in fog so thick that visibility did not exceed 30 meters. From the east, Germany's 113th Panzer Brigade, fielding 42 Panther tanks, advanced into the Aracourt area, believing they faced only a few weak Sherman units. According to the campaign diary of Oberst Karl Hoffmann, the mission is to break through the American line within 3 hours and seize the Saragouis mines, Nancy route. None of them knew that, within the mist, the first Hellcats of the 704th Tank Destroyer Battalion were already waiting. The 704th Battalion, recently re-equipped after the Italian campaign, had been assigned to support the 4th Armoured Division. Lieutenant Edwin Leiper, Company C, led a platoon of Hellcats in the area of Rosières-la Petite. According to the after-action report, 704th TD Battalion, September 1944, vehicles were in position from 3:45, engines idling, visibility under 40 meters, radios maintaining constant contact. When a massive silhouette emerged through the fog, Leiper ordered fire. The first shot penetrated a Panther's flank at a range of 30 feet. The second ignited it in an instant. Within the first 5 minutes, 5 Panthers were destroyed, while one Hellcat was hit by return fire and burst into flames. Chaos spread rapidly. The 9th Army Ordnance Report recorded, "The Hellcats accelerated to 30 miles per hour, changed positions within 6-7 seconds, avoiding counterfire from Panthers whose turrets took 60 seconds per rotation. In that moment, speed became an unstoppable weapon. Gunner James E. Dempsey recalled, "We fired, then we ran. When the smoke cleared, the only thing left was their burned-out steel frames." The shoot-and-relocate technique they had learned in Italy now became the key to survival on the fields of Lorraine. By 8:30, both sides temporarily lost contact as radio signals were disrupted. However, the SCR-508 radio system in the Hellcat remained more reliable than German communications, allowing American platoons to coordinate fire, a recording preserved in the US. Signal Corps archives captured a short order on Channel C. Alpha 1, flank left, target 200 yards, 2 Panthers burning. As the fog began to lift, American artillery from the 11th Marines opened supporting fire, cutting off any German counterattack. According to Combat Command A, 4th Armoured Division, from 9 to 12, the 704th TD Battalion destroyed 10 additional German tanks, losing 2 Hellcats and suffering 3 lightly damaged. On the battlefield, the contrast between the two mechanized philosophies was stark. The Panther, weighing 45 tons, with a top speed of 29 miles per hour and a 7-ton turret, could not rotate quickly enough when attacked from the flanks. In contrast, the Hellcat, weighing 20 tons, could accelerate to 30 miles per hour within seconds and complete a full turret rotation in 15 seconds. At Aracourt, those dry figures became the line between life and death. A captured German crewman stated in a post-battle interrogation, "We saw the flash, then we lost our comrades. They moved too fast like predators in the fog." By the afternoon of September 19, Sergeant Henry R. Hartmann's platoon had taken position on the southern flank, where the terrain was flatter. Within 2 hours, Hartmann commanded 3 Hellcats that destroyed 6 Panthers, scoring direct hits on turret fronts and hull joints. According to the U.S. 3rd Army Tactical Report, Hartmann's crew achieved the highest confirmed tank kills in a single morning of the campaign. Meanwhile, German forces began retreating in disarray, abandoning many tanks due to final drive failures, a chronic weakness of the Panther at high speeds. On September 20, the battle resumed as the 111th Panzer Brigade was committed as reinforcement. By this point, the Hellcats had mastered the bait-and-flank tactic, using one platoon to draw enemy fire, while 2 others closed in from the sides. According to 9th Armoured Division records, by combining radio coordination and speed, the 704th turned the battlefield into a moving labyrinth, where the slower side always lost. By noon on September 21, the Germans had lost 13 more tanks, including 5 Panthers destroyed after mechanical breakdowns while pursuing the Hellcats. A German report to the Western Command stated briefly, "Feindliche Panzerjäger außergewöhnlicher Geschwindigkeit, keine Verfolgung. Enemy tank destroyers of extraordinary speed, do not pursue." When the sun broke through the fog on September 25, the Battle of Aracourt officially ended. Final statistics: 39 German tanks destroyed or abandoned, 4 Hellcats lost, 3 damaged. The figures were confirmed in the Army Ground Forces Statistical Digest, 1945, classifying Aracourt among tactical engagements with decisive outcome. The 6-day battle proved that speed and communication could defeat firepower and armor. After the war, military analysts called it the turning point of mobile doctrine, according to the U.S. Army Historical Review. Volume 8. Aracourt shattered the German assumption that tank warfare depended on armor thickness. It was in Lorraine that Lieutenant Colonel Bruce's idea, "speed is armor," was validated in blood and steel. A surviving German officer said in a 1947 interview, "We did not lose because our guns were weak, but because the enemy refused to stand still to be shot." When American artillery finally fell silent, smoke still drifted across the meadows. A few Panthers continued to burn, their turrets twisted by the blast of 76mm shells. One Hellcat from Leiper's platoon was hit, but its crew survived. They sat beside the wreck, silently watching across the grey haze of the battlefield. One of them later said, "We understood then it wasn't a victory of tanks, but a victory of thought." And in that fog, the old war ended. After Aracourt, the U.S. Army Command began compiling data to assess the actual performance of the M18 Hellcat. The results made Buick engineers proud and left the enemy astonished. The combat readiness rate reached 78%, meaning that at any given time, more than 3/4 of the vehicles were fully operational. According to the U.S. Army Ordnance Service Report, October 1944, the M18 achieved the highest readiness rate in the entire U.S. mechanized force, surpassing both the M4 Sherman and the M10 Wolverine. Behind that dry statistic lay a complete industrial, maintenance, and design system optimized for modern warfare, something Germany had never achieved then. The mechanical reliability of the Hellcat was proof of the American philosophy of industrialization. Buick's torsion bar suspension allowed the vehicle to maintain 40 miles per hour over rough terrain while keeping directional stability. Combined with the torque drive automatic transmission, drivers could change direction instantly, evade counterfire, and reposition without losing speed. According to tests conducted by the Army Ground Forces Test Board, November 1944, a Hellcat could accelerate from 0 to 30 miles per hour in 11 seconds, while the Panther required nearly 30 seconds. On the battlefield, that difference meant survival. As soon as the gunner fired, the driver would hit the throttle, treads biting into the ground, the entire vehicle shifting course before the enemy's round arrived. The M18's ability to sustain continuous operation also came from its simple maintenance structure. The Wright R975 engine was mounted on a sliding frame and could be removed in just 2 hours without a crane, while the same task on a Panther required 24 hours and a specialized crew. According to the Buick Engineering Memo 1944, the Hellcat's modular assemblies consisted of 8 major components, all replaceable on the spot even in the middle of a battlefield. This design allowed an M18 company to maintain near-continuous combat readiness for 72 hours without withdrawal for servicing. A technical officer of the 704th TD Battalion recorded, "When a vehicle broke down, we didn't call for a tow truck, we opened the toolbox and swapped the engine. 2 hours later, the Hellcat was roaring again." If mechanics were the foundation, then psychological warfare was the hidden force behind every battle. After the defeat at Lorraine, German troops began to view the Hellcat with a mixture of fear and confusion. A diary from the 113th Panzer Brigade, captured at Nancy in October 1944, read, "We heard the Hellcats before we saw them. The engines roared and vanished, followed by flashes and fire, the distinctive sound of the Wright R975 engine echoing through the fog made Panther crews feel hunted. According to the interrogation report of captured German tankers, 1,945, many soldiers referred to the Hellcat as the Geist der Steppe, the ghost of the plains. It was not just fear of a weapon, but a collapse of faith in the war doctrine they once believed flawless. Within the Wehrmacht combat system, every tactic was built upon the principle of controlled maneuver. Panzer units typically attacked in wedge formations, using the lead tank as the breakthrough point. But when facing the Hellcat, this tactic collapsed. The lighter, twice as fast Predators struck from unpredictable directions. At Aracourt, within 5 minutes, 5 Panthers were destroyed without ever locating the enemy's position. When the report of failure reached headquarters, General Hasso von Manteuffel, commander of the 5th Panzer Army, was forced to issue a new order. Feindliche Panzerjäger außergewöhnlicher Geschwindigkeit. Keine Verfolgung. Enemy tank destroyers of extraordinary speed. Do not pursue. It was the first document in Wehrmacht history acknowledging that a German armoured force was no longer mobile enough to match its opponent. That sense of defeat ran deeper than any map line. In post-war interrogations, many German officers described the Hellcat as the enemy that made us fire into empty air. One of them, Oberleutnant Karl Reiner, who had commanded a Panther platoon at Aracourt, recalled in a 1946 interview, "We once believed everything could be destroyed with enough armour and guns, but this thing didn't stay still to be aimed at. It moved faster than our decisions." That confession was proof that superiority came not only from technology, but from how the Americans changed the rhythm of battle. Back at home, Buick engineers began to recognize the psychological impact of their creation. A veteran engineer wrote in the internal bulletin Buick War Chronicle, "We have built a vehicle that makes the enemy afraid before they even see it." On the battlefield, this was reflected in American tactical intelligence reports. According to the Army Intelligence Summary, November 1944, German units on the Western Front often delayed counterattacks upon hearing the sound of Hellcat engines in the distance, believing the enemy had overwhelming numbers. From a mechanical weapon, the Hellcat had become a tool of psychological disruption, a form of invisible warfare that eroded enemy morale. By the end of 1944, the Hellcat had proven that victory was not measured solely by firepower or armour, but by reliability and reaction speed. On the Lorraine front, the U.S. 3rd Army Operations Review recorded, Hellcat units maintained continuous operational capacity of 78%, a record unmatched by any armoured formation. That cold statement concealed a deeper truth. American mechanization had advanced so far that Germany could no longer adapt. Across Europe's misty fields, the burning Panthers became symbols of an old era, while the Hellcat moved forward not for speed's sake, but for a philosophy that had transformed the entire doctrine of war. For German generals, the order, "Do not pursue," was a tactical humiliation. For the Americans, it was proof that a machine built in Detroit could defeat the war doctrine of Berlin. And in the final reports of the year, the briefest line carried the greatest declaration, "The Hellcat ran faster than fear itself." In the spring of 1945, as Europe lay in ruins and the last guns of the Wehrmacht fell silent, the US War Department began one of the most comprehensive evaluations in the history of modern mechanization. Thousands of pages of documents, journals, maintenance logs, and battlefield statistics were compiled to extract strategic lessons from the greatest armoured conflict of the century. Among these records, the M18 Hellcat files were marked Priority High, as they represented the success of an entirely new weapon philosophy: speed instead of armour, agility instead of brute force. According to the United States Strategic Bombing Survey, European War 1946, Hellcat was the only Allied vehicle to consistently outperform German armour in both mobility and reliability. The figures were carefully compiled. 526 enemy vehicles destroyed, including 498 inches Europe, 17 inches Italy, and 11 inches the Pacific. In total, the Hellcat tank destroyer force lost 216 vehicles from all causes, including combat, mechanical failure, and accidents. The kill-to-loss ratio reached 4 to 1, the highest among all U.S. armored forces during the war. On the European front alone, the ratio stood at 3 to 1, far surpassing all other tank types. Compared with the M4 Sherman, average 2 to 1, and M10 Wolverine, 4 to 1, the Hellcat became living proof of the effectiveness of the doctrine, speed is armor. In the Army Ground Forces Summary 1945, engineers analyzed each technical indicator to explain this phenomenon. The Hellcat reached 55-60 miles per hour on the road and 26 miles per hour on rough terrain, while the Panther managed only 29 miles per hour on the road and 15 miles per hour cross-country. The M18's turret completed a full rotation in 15 seconds, 3 times faster than the Panthers, allowing the crew to respond instantly to threats from any direction. The SCR 508 FM radio system enabled coordination in 5 seconds, compared to 30 seconds for the German AM radio, whose interference and delay often left commanders unable to issue real-time orders. That 25-second difference, in the fast-paced world of mechanized warfare, meant the distance between the shooter and the target. These data laid the foundation for extensive discussions at the U.S. Armored School, Fort Knox, in 1946. For the first time, the U.S. Army formally acknowledged a doctrinal shift from armor superiority to mobility-based defense. In the training manual FM 17-10 Armored Combat, instructors wrote, "A fast unit can dictate the tempo of war. The Hellcat became the defining example of a tempo-dominant weapon." General Jacob Devers, summarizing the Lorraine campaign, declared at a conference in Kentucky, "We don't need more steel, we need faster decisions." That line would later be cited throughout NATO literature, becoming a central axiom of post-war mechanized warfare. Beyond tactics, the war left an industrial lesson. In 1947, a group of experts from the War Department Technical Division published a post-war analysis titled Production and Power: Comparative Industrial Lessons from the European War. The report stated, "The United States did not win by outbuilding Germany in tanks, but by outthinking them in design philosophy." Specifically, each Hellcat cost $57,500 to produce half the $117,100 Reichsmarks price of a Panther. Each Hellcat required 500 man-hours of assembly compared to the Panther's 2,000. That fourfold difference allowed the US to replace all combat losses within 2 days, a production capability far beyond Germany's reach at the time. According to the Buick Engineering Review 1947, the assembly lines that once built the Hellcat were converted to civilian use after the war, though many of their technologies were retained for new military projects. The torque drive transmission, Wright R975 engine, and modular assembly structure became the precursors to the concept of standardized armored components, later adopted by NATO for its Joint Combat Vehicle program in 1949. The Hellcat ceased to be merely an American weapon. It became a model of technical unification for the Western defense bloc. The doctrinal influence extended beyond engineering. When NATO was founded in April 1949, American, British, and French officers directly referenced Hellcat combat reports to shape the concept of flexible response. The NATO Training Manual No. 121949 stated, "Speed, communication, and mobility provide a tactical advantage superior to armor and firepower." Here, the philosophy of communication over armor was officially defined, marking the beginning of the networked warfare era, where radios, radar, and data replaced steel and gunpowder as the decisive instruments. A young British officer, later to become NATO's first Secretary-General, wrote in his notes, "From a single Hellcat in Lorraine, we learned that victory lies not in mass, but in the speed of information." Post-war, many German mechanized historians also acknowledged that the Hellcat changed their understanding of speed. In Panzertruppen Reassessment 1948, former General Heinz Guderian wrote, "The Hellcat was not stronger, but faster." and that changed the nature of the contest. He described the Battle of Aracourt as a break point of thought, where the German doctrine built on heavy armor and concentrated firepower was neutralized by dispersed, mobile tactics. The General Inspecteur der Panzertruppen report that same year concluded, "Victory in mechanized warfare is no longer possible when the enemy can react twice as fast." It was a rare public admission from what had once been the world's leading tank force. Yet the deeper impact lay in organizational thinking. The Hellcat forced the US Army to reconsider interbranch coordination. During the Fort Knox seminars in 1948, commanding officers concluded that tanks, infantry, artillery, and air support could no longer operate separately but had to function as an integrated communication network. The Combined Arms Doctrine Study 1948 stated, "Hellcat proved that coordination is the armor of the modern age." This principle became the foundation of the Combined Arms Doctrine later adopted by NATO. According to the Office of Military History Summary 1949, data from the Hellcat program formed the basis for two major innovations: the standardization of FM radio across all armored vehicles and the prioritization of engines with a power-to-weight ratio exceeding 15:1. These seemingly technical parameters became the guiding principles of a new era. By the end of 1949, the U.S. Army had completed the installation of the AN divided by VRC-3 radio system, a direct descendant of the SCR-508, the radio that had enabled the Hellcat to coordinate fire and command in 5 seconds, compared to 30 seconds for its German counterpart. The speed of command transmission became a symbol of the new century, where victory would be decided by data, not steel. Later, historians would call the Hellcat the first digital tank, a vehicle that embodied digital thinking before computers existed. It inaugurated a concept that modern militaries still invoke: network-centric warfare. An engineer who had helped build the Hellcat remarked at a Flint symposium in 1949, "We didn't know what we were creating. When they drove that vehicle to the battlefield, they carried the future with them." By the late 1940s, as the world entered a new order, the Hellcat had fulfilled its historic mission. From the foggy fields of Lorraine to the classrooms of Fort Knox, from Buick's production lines to NATO's founding charter, the M18 was more than a combat vehicle. It was the seed of a doctrine. It proved that mechanization was not merely a story of speed, but a story of industrial intellect and modern organizational warfare. And in the final summaries, one short annotation appeared at the bottom of the page. The M18 Hellcat redefined the limits of mobility, and with it, redefined the future of war. After the war, as the US mechanized columns withdrew from Europe, most Hellcat units were moved into storage. Yet even in peacetime, the M18 continued its journey no longer as a symbol of combat, but as proof of the endurance of design. In 1949, the U.S. Department of Defense decided to convert 650 Hellcats into the M39 Armored Utility Vehicle, a light armored troop and transport carrier. The turret was removed, the hull reinforced with seats and shielding, while retaining the torsion bar suspension and Wright R975 engine. According to the U.S. Ordnance Conversion Report 1950, the Hellcat chassis allows flexible conversion without loss of stability. During the Korean War, the M39 served in reconnaissance and artillery transport units, operating in mountainous terrain that heavy tanks could not traverse. The 8th Army Logistics Division's post-war report recorded, "The M39's failure rate remained under 7%, proving mechanical efficiency after more than a decade." Beyond its tactical role, the M18 left a lasting mark on post-war European military thought. When the Bundeswehr, the new West German army, was re-established in 1955, many German advisors who had served at Lorraine were invited to join mechanized training programs. Among them were former officers of the 113th Panzer Brigade, the unit that had faced the Hellcat in 1944. They carried with them bitter memories of an enemy that moved faster than they could react. During seminars in Bonn, they recommended avoiding heavy tank development and focusing on mobility and maintenance. According to the Federal Defense Ministry Memo 1956, the group proposed a new direction for the National Tank Program. Light chassis, modular engine, fast turret. That philosophy became the foundation for the Leopard 1, launched in 1965, the first post-war German tank designed around the concept of speed instead of armor. The influence of the Hellcat did not stop with Germany. In NATO military academies, the Hellcat was studied as a prime example of the mobility-based doctrine. At the Royal Armoured Corps School, Bovington, in 1960, a lesson titled Hellcat at Aracourt was added to the curriculum. Young officers from Britain, Canada, and France learned to analyze the shoot, shift, survive tactics, move, fire, and withdraw within seconds. They came to understand that speed was not just a technical specification but a means of controlling time, the decisive element of every modern battle. One British instructor remarked, "The Americans did not build the best tank, but they built the most time to decide on the battlefield." In the United States, that mindset evolved into the foundation of technological progress. From the Hellcat, engineers moved on to develop modular, easily maintained, and increasingly automated vehicles. The torque drive transmission system became the precursor to the drive mechanisms of the M48 Patton and later the M1 Abrams. According to the Army Development Command Report 1973, designers noted, Abrams inherits the Hellcat philosophy, speed, mobility, and field repair capability. This philosophy even influenced Israel's Merkava tank program, when Colonel Israel Tal's engineering team studied the Hellcat's design during the 1970 seconds. He once said in an interview, "The Hellcat taught us that a weapon built to endure doesn't have to be the strongest, it only has to adapt." That cross-century influence was reflected in how the world came to understand tactical mobility. In 1978, NATO officially introduced the concept of mobility and survivability balance into Standardization Agreement No. 2027, recognizing the Hellcat as the doctrinal precursor to modern mechanized warfare. With that vision, post-war generations of tanks were no longer judged solely by armor or firepower, but by their ability to maintain continuous operation in fluid combat environments, the very capability the M18 had proven in 1944. From a cultural perspective, the Hellcat also became a symbol of an industrial America, where engineering intellect met the realities of war. In U.S., Army Signal Corps documentaries of the 1950 seconds, the Hellcat often appeared between shots of the Buick assembly lines and battle footage from Lorraine, reinforcing the link between factory and front line. A former Buick worker who attended a screening in Detroit in 1957 recalled, "When the engine roared on screen, the whole audience stood up. They knew they had built that with their own hands." 30 years later, in 1985, the small town of Aracourt became a place of reunion. In the meadows once shrouded in smoke, a ceremony was held to commemorate 40 years since the victory in Europe. American and German veterans, now grey-haired, sat side by side. A Hellcat, restored by engineers from the Yankee Air Museum, was driven across the old battlefield. When the Wright R975 engine roared to life, its familiar sound echoed through the Lorraine Valley. The vehicle accelerated to 50 miles per hour, a figure still astonishing after 4 decades. The French press reported, "The German veterans stood silently. In the fading light, they seemed to see what they had lost at 20. That moment meant more than a parade. It was the meeting of 2 generations engineers and soldiers who had once stood on opposite sides of a philosophy of war." When asked for his thoughts, a former Panzer officer replied briefly, "Back then we lost because we believed too much in steel." Beside him, a former Hellcat driver of the 704th TD Battalion smiled, "And we won because we believed in speed." Their words lingered in the Lorraine dusk, carried by the wind and the faint scent of oil and smoke, closing a circle of history that had taken 40 years to complete. As night fell, the lights reflected off the Hellcat's time-worn steel body. The veterans touched the faded silver-grey paint, feeling the welds they had once placed there. A journalist wrote in his report, "They said nothing, just stood still, as if the speed of history was still rolling around them." In Aracourt, 1985, among those who had survived the war, the Hellcat was no longer a weapon, it was a witness. A symbol of an era when humanity learned that victory was not found in thick armor or big guns, but in the ability to change. And in that silence, they all understood a truth forged in steel and speed. Speed had defeated steel.